So we're measuring the first sample there and then moving off, and you can see we're going to move to a different location. We've indexed round to the next part. One thing to note here is that the weight of this is offset, but it is counterbalanced. There is a counterbalance inside here to make sure that the weight is balanced evenly about the spindle axis. So when we're measuring on the carousel, there is no loss of accuracy, and we'll have a look at some of those results in a minute. So what sort of results do we get? Well, for those 20 samples that we've just seen, what we did was we took the 20 samples and we measured them 20 times, 20 runs here down the left, and across the top the results for each of the 20 samples. And in this case we were just looking at the roundness in nanometers. So for example, for sample 1, these are the results on each of the individual runs, and the standard deviation was only 5.3 nanometers with a spread, a deviation of max to min of only 21.7 nanometers there. And so typically we will get below a spread of about 30 nanometers, and in this case we got a extremely low standard deviation of less than 10 nanometers for these results, and that really compares perfectly well with just measuring a single part. And that's the key to this device. We don't lose accuracy when we do measurements. Not only can we measure the parts you saw, but we can also measure roller bearings, ball bearings, injectors, medical components, hip joints, and teeth implants.